All right, guys, here's your review for Unit 6. Okay, so we're going to start with the first page, which is about the sequences. All right, so what you need to do here is we need to look at the pattern. So the pattern of this sequence right here is, let's zoom in this a little bit. Okay, we're going from 2 to 6 to 18. Well, that's going to be times 3. So times 3 for the pattern. Okay, and then the next term, well, we're going to have to multiply 3 to get to the next term. So what I'm going to do is I'm going to actually take out the calculator here. I'm going to do 54 times 3. So that's 162. So that's our next term. So basically, it's the next term after this one. Okay, so 162. What type of pattern is it when we are multiplying? That's going to be a geometric, which is also exponential. So again, the biggest things we got to recognize is what kind of pattern are we dealing with? Some of you guys might think it's like add 4 or add 12, but notice that it's not the same between each number. So that must mean it's probably geometric. Okay, so now the first term, remember we always start with 0 in our table. Okay, then after that, it's just, 1 goes by 1. So 1, 2, 3, 4, 5, 6, and 7. And then we just write out the 0th term, which happens to be 2. Okay, and then after that, we're just going to keep on multiplying. So 6 times 18 6 times 3 times 3. We're just going to keep on multiplying 3 here. And what I'm going to do is to bring out the calculator so we can go ahead and do that. So we're going to do times 3 again. 3. So 486 is the next one. And then you can tell this is probably going to start getting kind of big. Times 3 again, so 1458. And I gotta do it one more time. 8 times 3, 4374. Okay. All right, then the last part is we got to set up our equation. So remember now with an equation that is geometric, we're going to want to put it in this form. T of n equals a, which is our start value, and then times b, which we put in parentheses, that's our rate or our pattern. And then all that raised to the nth power. So our starting point is going to be 2. And then our pattern is 3. So that goes in here. Okay, so that's how we set up the equation. All right, next one. Okay, so now I'm going to look at C. This is going down. And notice from here to here that it is minus 20. And then it's the same thing from here to here. So minus 20. So that's going to be our pattern. So this is minus 20. Okay, the next term after that, well, we just subtract 20. 23 minus 20 is 3. Okay, so again, there's our 0th term. So that's going to be our first one in there. Okay, so we're going to go by ones here on the top. This always pretty much is the same thing. You always go 0, 1, 2, 3, 4, and so on. Okay, and then after that, it's minus 20. So minus 20, 63, 43, 23, 3, and then 3 minus 20. It's going to be negative 17, minus 20 again. That's going to be negative 37, and then negative 57. Okay. All right, so now this time we're just subtracting. Okay, so we're subtracting, which is an arithmetic pattern, which is also linear. So remember, these will always match. You always either have arithmetic and linear or geometric and exponential. Okay, they'll always be matched together. Now the equation for an arithmetic pattern goes like this: T of n, and it's just like y equals mx plus b. So it's m, but instead of x, we do the letter n, and then plus b. Okay, so we write it out just like that. Okay, so we're going to do T of n, and the m, again, is your pattern. The b is the starting value. So going back to here, I'm going to highlight this is the pattern, and this is the starting value. So it's kind of like it's flipped around. Over here, we start with the pattern, and then the start value. Here, we start with the start value, then we end with the pattern when we set up the equation. Okay, so again, the pattern is minus 20, so negative 20, negative 20n, and then it's a positive 83, so we're going to plus 83, okay? All right, so now again, same thing down here, explicit rule and recursive rule. When you see the word rule, that literally means the exact same thing as equation. So this is just asking you to write the equation. So that's nothing new. It's just another way of saying the same thing, okay? So again, here's our starting value. All right, let's see what's happening here. It's going down pretty rapidly. So from here to there, looks like dividing, but I'm not really sure what number it is. So what I'm going to do is I'm going to do 60 divided by 80. Okay, and if I do 60 divided by 180, that's going to give me the pattern. Because remember, you can do one term divided by the one before, and I get 0.333. If I hit this button, it'll make it a fraction. And remember, you can also do that in the calculators in class. So that means that the pattern, or the m, okay, actually in this case, it's multiplying. Okay, so that's actually the b, is equal to 1/3. Okay, so the explicit rule is going to be t of n equals the start value, 540, times the pattern, 1/3 raised to the n power. And now remember, recursive rule, all we're doing is doing t of n plus 1. So remember, every time it's recursive, we do t of n plus 1 equals t of n. And that'll be the same thing whether we're doing arithmetic or geometric. And then since it's geometric this time, what we're going to do is just write times whatever the pattern is. So in this case, it was 1/3. Okay. All right. So now for the next one, arithmetic pattern. There's the start. Okay. Notice it's arithmetic because from here to here, we've got, looks like we're going actually increasing. So this is actually increasing by adding 4. Okay. So then we're going to start with t of n and 4n. And then we're going to add the start value, which is negative 23. So we're going to put minus 23. So that's the equation for the arithmetic pattern. Okay, so now we're going to do the recursive pattern. And we write t of n. And because it's it's arithmetic this time, and we're adding, we're just going to put plus 4 at the end of this equation. Okay. All right. Okay, going on down to, now we're going to talk about domain. Now, with this domain, remember that, what color are we using? We're going to use blue for domain and pink for range. Okay, so remember, domain has everything to do with all your x values, whereas range has everything to do with our y values. Okay. Now, you notice that it's just a bunch of points, right? So what we're going to do is we're going to take all the x values of each of these points and write these out and list them out. So right here, this point is negative 2, 0. This one is 1, 3. This one is 4, 1. And then this one is 0, minus 4. All right, so what I'm going to do is I'm going to list out all these x values, starting with negative 2. Then the next one is 0. The next one is 1. And then 4. And then all I do is I close that with braces or these brackets there. Okay, so now range is just the y values. I always usually list them starting by the lowest value. So right here, I'm going to start with negative 4. Then the next one up would be 0. Then here would be 1. And then the last one would be 3. And again, I close that with these little squiggly brackets, or what we call braces. Now remember, for function or yes or no, all I do is I do the line test, right? So if I had like a line, I'm going across my graph, does it touch any of these points more than once at the same time? In this case, it's a no, okay? Because every single time I pass the line through here, it does not go through more than one point. So, oh, my bad. I meant to say yes. It does not go through each point. So it's actually a yes, my fault. All right, so now this one, domain. Now this starts at one point and ends at another. So we're going to have values on each side of this. And this is a continuous line. It's not a bunch of points. So because it's a continuous line, we're going to write our domain like this, where all the values are less than x and then also greater than x. Okay, and everything in between basically is the limit or the domain of this graph. Okay, so again, we're still going to be focusing on X for domain and Y for range. So starting with domain, all the way to the left, the furthest X value to the left is going to be -5. The furthest X value to the right is going to be +7. So we have 7 over here and then -5 to the left. Okay. Now, again, same thing for range is less than or equal to Y this time because it's range. And then we just need to figure out the lowest value and the highest. Okay, so the lowest Y value, again, here is going to be -2. And then the highest Y value is going to be right here at 4. So it goes from -2 to 4. Okay, is this a function? I pass my line over it like this. It doesn't touch more than once, so that is yes, a function. All right, so that's your video for page 1.